Hello, this is Mr. Stewart bringing you the 7.3 triangle side lengths. This is the third installment of the triangle quizzes. There are 3 quizzes in total about triangles. And this one addresses specifically how to tell if you can have a triangle with 3 given side lengths, or what are the properties of triangle side lengths. Let's just go ahead and dive right in. So the first question reads, and I will highlight this as I go, fill in the blank using the word blank below to correctly complete the statement. The sum of the 2 blank sides of a triangle must be blank, then the largest side of the triangle. So this question is testing your understanding on the definition of side lengths of triangles. And the best thing to help you would be under your Chapter 7 Computer Discoveries activities. There was an activity we did in class that involved side lengths. What I'm going to do is set this up so that we can just kind of take a look at this. Okay. Now what I have here are 3 side lengths. A side length of 6, which you can see here. A side length of 1, which you can see over here, and a side length of 4, which you can see over here to the right. Now as I change these around, these 3 side lengths, basically a triangle, you need three sides to a triangle. But the question is, if given this side length of 6, could I attach the 4 and the 1 and bring them around and join them together to make a triangle? And I think the answer is pretty clear, no. No matter how hard I try, I cannot create a triangle here. I cannot build a triangle here, which is kind of an interesting idea. Okay. Now the circles that you see are the path at which the 4 and the 1 would take in any direction I swivel them. So you think to yourself, okay, what would be required of these side lengths in order for them to join up? And you might say, well, I could make the 4 longer, or the 1 longer, or shorten the 6, and that's kind of the point here. I'm going to make the 1 longer. I increased it by 2. Now that I increased it by 2, as I move this over, I can see that right here there is a cross section that allows me to be able to join the C, the point C, and the point C, the other point C, to join up together to create a triangle. So the answer to this question is, I can create a triangle with these 3 side lengths. Now, here's the point I want you to understand. Okay? When I was given a side length of 6, this was classified as the longest side. Now the other 2 side lengths, they have a length as well, but they are not as long as the longest side, so they're the 2 shorter sides. And you could kind of argue that every triangle has 1 longest side and 2 shorter sides. And some of you would say, well, no, that's not true, Mr. Stewart. What about an equilateral triangle or an isosceles triangle, where 3 of the side lengths are the same or 2 of the side lengths are the same? And I have an answer to that, but we'll talk about that later. Okay. Now the point of this is, if I added these 2 up, if I found the sum of these 2 shorter sides, 4 plus 3, what do I get? Okay, that equals 7. And the question is 7 greater than 6? And I think, the answer is very clear, yes, it is. So the point is, if I measure this side length here, then the other 2 side lengths that are branching off of it must be longer than the longest side length. Because, and I'll erase this just to show you, if it's not, like let's go back to the example where I had 1. If I took the 2 shorter side lengths, 1 and 4, and added them together, I get 5. And if I am comparing it to the longest side length, which 6 still is, then this time the longest side length, 6, is longer than the 2 shorter side lengths combined. And there's no way, because they are not long enough, that these can match up with each other. It's just not going to happen. So we would say that the longest side must be smaller than the sum of the two shorter sides. There's one example I want to show you that, well, there's actually a few other examples I want to show you, and then once you get this point, everything else from this quiz is going to make a lot of sense, I think. Now let's look at this example. I think I'm going to drag this in and drag this in, and a lot of students would look at this and go, ah, Mr. Stewart, I created a triangle. So some students would say that the sum of the two shorter sides must be at least as long. But let's think about this logically for a second. Let me zoom in. If you zoom in, you'll discover they're not exactly touching, so I'd have to bring it in a little bit closer, bring it in a little closer, and then you say, surely they're touching now. I definitely have a shape that is very small, but it's probably still a triangle because it probably still has three angles of some kind. So then we zoom in even further and we discover that they're not touching. I mean, you can zoom in even further if you wish, but they're definitely not touching. And you could keep doing this and doing this and doing this, thinking that they're going to touch, but eventually you're going to think to yourself, okay, the one place I know for sure they're going to touch is when this line matches up with that line, and this line matches up with this line. The reason I know that is because the line that the two shorter sides are resting on is 6 long, and the two shorter sides add up to be 6. So the reason I know that that's where they're going to line up is because 2 plus 4 is 6. But then when you look at this shape, the unfortunate thing about this is it is no longer a triangle. It is two lines resting on top of another line, which by definition is a line. So there's not a triangle here. This is not a triangle. So you need to understand that the two shorter sides must be longer, strictly longer or larger, however you want to word it, than the longest side. So in this case, this is not a triangle, not a triangle. Okay, let's create two more triangles. Let's do an isosceles triangle. Okay. Here's an isosceles triangle. The sum of the two shorter sides is 8. The longest side is 6. I can create a triangle here. Let's do another isosceles triangle. Take a look at this. This is an isosceles triangle. The sum of the two longer sides, now this one's tricky because some people will look at this and go, okay, Mr. Stewart, which one's longer, this one or this one? And I would just tell you, okay, look, it doesn't really matter. When you have two sides that are the exact same length, just pick one to be the longest and then call the other two the shortest. The sum of the two shorter sides, is it longer than the longest? 6 plus 4 is 10, which is bigger than 6, so yes, I can create a triangle with this. And you can clearly see that I have created a triangle with this. It's an isosceles triangle. The last one we're going to create is a 6 by 6 by 6 because that is an equilateral triangle. And again, this is one of those things where, you know, if you think about it logically, then yes, clearly, anytime I have 3 side lengths that are the exact same length, I can always create a triangle with them. It's an equilateral triangle. But if you're worried about the definition, again, just pick one of the 3 to be the longest and consider the other 2 to be the smallest. Is the sum of the two smaller sides, which is 12, bigger than 6? The answer is yes, so I can have a triangle here with plenty of room to spare. So that is the entire definition of triangles. The video tutorial talked about this. I'm talking about this now in this video tutorial, and we spend an entire day doing a computer discovery activity in class with this, and so hopefully you get this by now. Okay? So that should help you with your definition. Remember, in the blanks, just use the word bank and click in there and they'll pop up. Okay? All right. And this question reads, which set of side lengths could form a triangle? Select all that apply. So all you have to do is take the two shorter sides of each one, add them up and see if they are longer than the longest side. You'll have to be the one smart enough to identify which of the 3 are longer than the other 2. And then select all that apply. So, you know, these 3 could be a correct answer and these 3 would not, so you'd leave those blank. I don't know, I'm not gonna tell you, but I would just say, you know, that's gonna be helpful for you. to understand that. So a few of them are and a few of them are not. Just click on the ones that do form a triangle. Okay, this is question number 3. It's a long one, so I will make sure I talk. 2 of the side lengths of a triangle are given, 8 inches and 5 inches. Which side length could the third side be? Select any and all side lengths that the third side could be equal to, which would form a triangle. So what you're going to do is think to yourself, okay, if I have a side length of 8 inches and 5 inches, 8 inches and 5 inches, could a 2-inch stick, maybe that's a 2-inch stick, could that be the third side, and could I form a triangle with that? Yes or no? If it's a yes, check it. If not, leave it blank. And that's what you're going to do. Now be cautious, because there's going to be point. So 8, you might say 8 is the longest side. So basically, anything that I can take 5 and add to be larger than 8 wins, which is only true up to a certain point, because once I pass 8, from this point on, 8 is no longer the longest side. So my hint for you on this one is to understand that if I'm considering which one's the longest side, 8 will be the longest side for all of these, and then you just need to check. But once you reach 9 inches, 9 inches is the longest side. And then from there, you'll have to see if the sum of these two are longer than the longest part. The last question is very similar to question number 3 in that you're still checking to see which of the side lengths it belongs to. But if you think about it for a second, you could represent any possible solution to these triangle side lengths. Let me come up with just a quick example. So let's say I had like a side length of 5 and a side length of 2, let's say. Just making it up, so, All right, and so I'm thinking to myself, all right, how can I represent every possible side length of this third unknown side? So I'm going to have a third side. What could that third side length be if given the other two? And well, I want you to think about this. So let's just start. Could 1 be the third side length? 1 plus 2 is 3, which is not bigger than 5, so no. Could 2? 2 plus 2 is 4, which is not bigger than 5, so no. Could 3? 3 plus 2 is 5, which is not bigger than 5, so no. What about 4? 4 plus 2 is 6, which is bigger than 5, so yes, that one works. What about 5? 5 plus 2 is 7, which is bigger than 5, so yes. What about 6? Well, 6 is now the longest side, so I would say 2 plus 5 is 7, which is bigger than 6, so yes. What about 7? 7 is the longest side, 2 plus 5 is 7, so no. 8? No. 9? No. And I think you'll discover that after that, no matter how big that third side length gets, I won't be able to. So we'd say, okay, I can have a side length of 4, 5, and 6. But is that all the possible side lengths? A lot of you who understand what rational numbers are would tell me no. Actually, what about this number? What about 3.1? Is that a possible side length? What about 6.981? Is that a possible side length? And I think we would say yes, they are. They are all possible side lengths. They'd look really funny in those smaller sections, but they would still be possible side lengths that I could technically create a triangle with. So the question is, okay, how do I show if x were that third side length? If x were the third side length, how could I show all possible combinations? You look at this and think, okay, 3 is that point where it couldn't be 3, but anything bigger than 3. So x could be anything larger than 3. Except for it couldn't necessarily be anything bigger than 3, because I've also got this point here, 7, where it couldn't be anything, it couldn't be 7 or bigger, so I would also say x has to be anything smaller than 7. So as I'm looking at this inequality, this is telling me that x the third side length, could be any number as long as it's between 3 and 7, but not equal to 3 or 7, right? And that's an inequality. So this might help you in understanding how to set up this fourth one and where I'm coming from when I'm asking you about all the third possible combinations, which I think you might find interesting to know. There are an infinite number of solutions for x. It's still between 3 and 7, yes, but there are an infinite number of rational numbers between 3 and 7. So that's just kind of an interesting little note for you. So the number of types of triangles that I can make, unique triangles, are also infinite, which is interesting. I hope this video tutorial was helpful for you. If you struggle with it the first time, please retake it a second time very carefully, and good luck.